Besides voltaic cells, we can also talk about electrolytic cells. Electrolytic cells are cells where a non-spontaneous reaction has been forced to occur. Everything is still the same. For example, the anode is still the site of oxidation and the cathode is still the site of reduction. The only difference is the positive terminal and the negative terminal are switched from the spontaneous reactions from the voltaic cells. So for example, we can look at a molten salt like potassium chloride. Molten just means heated up till it turns into a liquid. If you carry out electrolysis on this, you're going to make pure potassium metal and pure chlorine gas. If you look at the oxidation numbers, the potassium is being reduced from a positive 1 down to a 0, and here is the reduction half reaction. At the same time, chlorine is being oxidized from a negative 1 to a 0, and here is the oxidation half reaction. We can also look at some stoichiometry with this electrolysis. In stoichiometry, an important measurement is the current, and current will be measured in units of amps. 1 amp is the same thing as 1 coulomb of charge per every second. So for example, if we switch to a molten aluminum salt and we want to measure how many grams of aluminum we're going to make, we know that in a salt, aluminum has a positive 3 charge. It's molten, so it's in the liquid state. It has to gain 3 electrons to turn into pure aluminum. So this important ratio between 1 mole of aluminum being produced for every 3 moles of electrons being used is the key to solving this problem. We're trying to figure out how many grams of aluminum could come from a constant current running for 1 hour, and that constant current is 25 amps. So we can rewrite 25 amps as 25 coulombs of charge per every 1 second of time. We're letting this run for an hour, so we have to turn hours into minutes, and then minutes into seconds, and now we can use the constant current of 25 amps to turn 1 second of time into 25 coulombs of charge. The amount of charge is related to the moles of the electron by the Faraday constant. 1 mole of electrons has a charge of 96,485 coulombs. Now that we've turned our charge into electrons, now we can use the balanced chemical equation that says 3 moles of electrons produce 1 mole of aluminum, and 1 mole of aluminum, molar mass 26.98 grams. So this is going to work out to be just over 8 grams of aluminum.